Our final talk of the session is given by Rick Morin from Mayo Clinic, Jacksonville, entitled Vetting Default Protocols, How Can Industry and Academics Work Together? Rick.
Thank you, Tony. Call sign Shark. Blue Jay. I'd also like to, no one's welcomed you to Atlanta yet. I'd like to welcome you to Atlanta, those of you that don't live here. Home of the great Emory University has produced some wonderful, wonderful graduates over the years. Before we get started, I'd like to see by hand raising, how many are radiologists? Would they raise your hand? Physicists? You can raise only one, thanks. Technologists? Vendors? Oh, you're proud. That's good. That's good. Neurologists, neurosurgeons? Oh, good. We can really bash those guys that don't know how to order cerebral perfusion studies. So we can really get into that. I was asked by Cynthia and Diana to talk about vetting the default protocols that the vendors supply when a CT system is installed. Either they thought that since I was in physics when it was invented, when CT was invented, so I must have done this at some point in time, which was true, but it was an ME Mark I scanner, and they're a little different now. Or she thought that I was sufficiently senior that I wouldn't tick off every vendor in the room in discussing the subject. For whatever reason, I'm very honored to be here and happy to talk about this. It's a very important topic. So, first question is, how are the vendor default scanner protocols determined? I mean, they arrive, and you can, theoretically, you can be a chiropractor and buy a CT scanner, and it will arrive with all the protocols that you want, and you can start scanning. You might not, never mind. Are they always optimal? Is there a rigorous process by which people determine the optimal imaging technique? I think it's important to understand that we are in an age now talking about optimization of imaging. We are at a time that we're talking about the optimal use of radiation. It's not just using low radiation, because we could easily do that. But as you just heard from excellent presentations, there's a trade-off involved in this. So it's the optimal use. So are they always optimal? Are they ever wrong? Well, we have some ideas about that, and we'll talk about that. And how can we work together into the future to assure that this process will yield better results for optimization of the use of radiation for high-quality CT images for our patients? I'd like to start off with a couple examples supplied by a couple of my esteemed colleagues, because we don't have any non-optimal stuff at our place. But at any rate, they provide, these are leading medical institutions in the United States. One of the things that is noted by many people is that the protocols that come from the major companies, which are international, they tend to be European-centric. So one of the things that we've heard that some institutions, the first thing we do with their scanner is increase all the default dose levels and choose a sharper kernel. This particular institution is not alone in this regard. If we take a look at the U.S. is highly litigious. Its diagnostic accuracy is the top priority. There's no question that diagnostic quality of the images is foremost for radiologists here. And we have high obesity rates. So therefore, the reference MASs tend to be a little bit higher, and the kernels tend to be a little bit sharper. In Europe, there's not as many lawsuits or malpractice. The dose limitations are often the top priority. In many, many countries, it is dose that drives the imaging equipment rather than image quality. And they don't necessarily have the same body habitus that we have here. So consequently, the reference dose values, or MASs, are a little bit lower, and the kernels that they use are a little bit smoother. They have to be smoother to smooth out the noise, because the noise is higher. So a good friend of mine, Bob Zeman, a number of years ago told another colleague that gave me this slide that I've gotten sued for missing findings on suboptimal images, but never for using too much MA. And I think virtually every radiologist in the States would feel somewhat the same way. You're not going to go to court because you had too high a dose, at least not yet. So another example of this, to set this up, is the following, which occurred at a major medical center in the U.S. The default protocols were used, and as you can see, there's this artifact. Now, the difference here is that one of them were scans at 5 millimeters, and the other ones were retrospectives at 2.5. So this physicist was called by he or she's radiologist that said, "Why are we getting these artifacts? I don't see them at 5 millimeters, but I see them at 2.5. What's going on?" So that this crack physics staff right away did the thing that any physicist would do. First of all, looked through the massive amounts of phantoms they had, because this is a very rich place, and found one that had a bubble in it. And that was very, very fortunate because, of course, as we all know, the bubbles are made of a gas, usually air, and therefore they're going to show artifacts better. Sure enough, when they used the same technique as a patient study, and they found out that at 2.5 millimeters, no artifacts, or at 5 millimeters, no artifacts, at 2.5, big artifacts. And then they started to change techniques. And they changed then the pitch and the detector configuration, and lo and behold, then the artifacts went away. So the take-home message here is that the image quality can be addressed and, in fact, improved while the dose actually went down. The effective MAS went from 109 to 100, decreased from 171. So the take-home message here is that, in general, if you use the smaller detector spacing, that's going to be better, and you can. It's more powerful than just decreasing the pitch to reduce the artifacts. So what this demonstrates is a nice interaction between the radiologists and the physicist. And I think that's one of the important points here that we're going to talk about with regard to protocols. We need to look at CT as a team approach. CT demands that we have dedicated radiologists, that we have dedicated medical physicists and technologists involved as a team, looking to optimize the image quality and the radiation exposure to the patient in order to deliver the best patient care that we can. So that's one of the big differences. If you take a look at another area where image quality has steadily improved and dose has gone down, it's mammography. Well, mammography was legislated by the MQSA. However, what does it demand? It demands a team approach. All three groups have to be there and working together, and that's important. An example of something that was just wrong occurred. This was given to me by folks that were part of the ACR accreditation group. When the initial MultiSlice scanners went from 4 slices to greater, the isocenter to tube distance changed. And so one would think that the MAS should go down because the tube is closer. Well, the problem is that these were scans submitted for accreditation. They used the thinnest collimation setting that they could, and instead of decreasing the MA, they used the same, and the result was that the old single scanner default was about 45 milligray for CTDI vol, and the multi-scanner one was 190. This was submitted to the ACR. Now, this was before you could fail for this, but it never occurred to somebody that, wow, this is a lot more than we did before. So this brings up another important point. We have an awareness issue. We need to make the community more aware of the radiation that they're using, what is appropriate, what is usual, and what is exceptional. If we only can get that across as a result of this summit and other activities of the AAPM and other organizations, we will be successful into the future. So, vendor supply protocols, how do they go about doing these things? Well, it starts at the factory, of course, and then some brilliant scientists and engineers come up with a new detector material, a new way to do this or that or the other thing, and so they develop a new CT system. They add more tubes. The Lord knows what they're going to do in the future, but they will do something. And so, therefore, the protocols start from the idea that we want to change the protocols to make use of this new technology that we have. And so they start out with some ideas about changing whatever it is they change, whether it's a standard head and they're going to change the reference MAS, or they're going to change the KVP, or whatever into the future. So it starts out with that. And then it will go to applications people, actually, which are usually former technologists that know how practices work. They'll tweak them a little bit, and then they go out to dedicated sites, so beta testing with partners, usually because this is at an early stage. The vendor wants to work with someone that they have a working relationship with, so that they can test out the protocols, so they can get clinical cases, so they can see where the equipment is truly being differentiating and how they can do things. Now, typically, the partners and the vendors, and that would be us, we haven't been as dose conscious as some others in other parts of the world. And so, therefore, the primary thing was study faster, better detail, just scan them head to toe and I can reconstruct them later for whatever I want and that kind of thing. And so that leads to protocol developments, and that leads to what ends up on the machines when they get shipped out. They generally do follow up, and they try very hard. Now, by the way, I'm speaking in general, but this is the result of conversations with several manufacturers, in fact, all the major manufacturers, and also places that do this kind of beta testing with partners with industry. So this is pretty much the way it goes. And then there usually is some sort of follow-up. Sometimes this is as formal as a consensus conference call, that they talk about a particular protocol or a particular portion of the scanner. A lot of times it's not. It's just a compilation by one person of talking to people and their, quote, impressions. This is not quantitative. This is the impression that people have with a particular protocol. So what options do vendors have with regard to supply protocols? Well, first of all, they could stop doing it, right? I mean, just don't supply any. Just tell the place that it's just like when Hounsfield developed CT, you're on your own, pal. Well, I don't think anybody would really want that. That doesn't sound too good, because it would be even worse a situation than we have now. Second is, now those of you that like the TV show Criminal Minds will recognize BAU as the Behavior Analysis Unit. You could make a case that maybe that would be a worthwhile thing to have, but in this case I mean business as usual. So just keep on doing things the way we're doing now, and we'll just try to do better next time. The other thing is that they could get we could have some sort of generic group that would get together that would take care of certain protocols. One of the problems working with partners is that very few institutions are worldwide experts in everything. They may have the best neuroradiology department in the world, but their body imagers might be, So it's unlikely that one place is going to come up with the optimal protocols for every part of the imaging that's being done. So instead, if you put together an expert consensus panel, and then you could arrive at some decision-making using an Adelphi approach or something like they do for the appropriateness criteria or something like that, now that would change the character of things. That way the protocols would be, quote, vetted a little bit better. Trouble with that, of course, is that most vendors have proprietary things in their new releases, and they don't want this spread around a lot. You could have a national consensus. You could have an umbrella organization like FDA that would convene a panel that would look at protocols and then decide and reach a consensus, much as they do much as the NIH does in consensus panels for medical imaging devices and things like that. Well, there's a lot of trade-offs here. One is that the feedback that the vendors get from the partners is not always very stringent and terrific. One of the things I heard from several vendors over and over again is that we would love to get more feedback. We'd like to know what is going on. So very often they may have good partners, but they may not get the feedback that they would like in order to optimize the protocols that they're going to be delivering, particularly to those places that don't have a lot of staff dedicated to the design, the review, and the examination of protocols. At the leading institutions that you've heard from already today, they do have people on board that do this kind of thing. But most of the CT is not done by those kinds of places. Most of CT is done by private practice groups. And they are most likely to just use whatever protocols are on the machine. So feedback is very, very important, and they want feedback. This is also, I think, for the physicists in the room, all of my conversations with vendors drew me to the point that they really do want to do the right thing. They very much want to do the right thing. They just want to know what the right thing is. And they're looking to groups like us to provide them with that feedback. The other trade-off is that it could be regulated. Many of people in this room were also at an FDA meeting a few weeks ago in which the FDA was talking about what things they maybe should do with regard to their regulations regarding equipment. They, of course, have a huge role in determining what can or cannot be part of a device or the explanation of how that device works. Regulations, of course, the vendors will have to abide by, but the other issue is that just by regulating it doesn't mean that you've optimized it for the given patients. Regulations are usually to prevent either bad behavior or mistaken behavior. They're not meant to optimize. Also, if you do this kind of thing, will it shut down innovation? Of course, the feedback in order to reduce dose is important, but realize that these companies are in business for a reason, and often it is innovation that has sparked the development of CT. It wasn't that many years ago that people were talking about the fact that the days of CT were the big days of CT were over. CT is plateaued out, MR is the big thing, and then Willie Collender basically said, well, not quite yet, and things changed. Things will continue to change in CT. There are new CT scanners being developed at major universities that some of you know about that are dedicated to certain anatomical parts that might shake up the entire way we do imaging of certain things. Additionally, the scientific community needs to step up to this issue. We need to step up to the issue that dose does matter, that we want to optimize dose, that it's time now to say that we're not going to just scan everybody the same way. We are going to talk about what the techniques are. We're going to work together to make sure our protocols are the best that they can be. Now, all of this has to be couched in terms of when we talk about the vendors supplying protocols, et cetera, it is ultimately for them about sales. No money, no mission. So it doesn't matter how highfalutin the idea is. If they don't make any money, they won't be around in order to do it. If we take a look at the literature and say, well, they should just use the protocols that are in the literature. Well, there is a problem. Houston, we got a problem. Number one, this could be years before the data come out as to what these protocols are really about, right? And that's a major problem. Everybody wants something evidence-based. It is very difficult to get evidence-based when you haven't done yet a blinded multi-institution study. Vendors have proprietary issues. They can't publish the things that are making them a market leader for a couple years. And no vendor wants to be a leader forever. Perfect example is dual energy CT. One company had it. It was very, very good, and they stopped. And the reason why? There was no competition. So they just want to lead. They want to lead for a while, and then they're going to let somebody else share in this new technology. We also have the problem that medicine itself is a cottage industry. We allow individual practitioners to do pretty much what they want within the law. And so therefore we see wide ranges of protocols that are maybe high dose but exquisite image quality. Whereas other radiologists would say, I don't really need that to see that adenoma or to see that renal calculus. I can get by with a lot less dose. So until we begin to come together with standards and say that this is what we think is the standard for a CT IVP, then how do we expect the vendors to know? And then lastly, of course, we have a culture change. We need to affect a major culture change. And I think that that is actually happening. We saw it at the FDA meeting. I think we're seeing it in the literature. We're certainly seeing it from the press and from the lay public, that we need to be more radiation aware. We need more awareness. For instance, this is from our place, in which when a perfusion scan is done, certain individuals will get an email into their box that tells the technique that was used, the length of the scan, et cetera, to make that person aware of what's going on with CT perfusion studies. So things like this allow us then to know so that we can then affect some change. So what's going to happen in the future? Well, I think things will get better. I think things are on their way. I think, for instance, many institutions now have, and we're seeing more of a drive to a protocol review committee. The department should have a committee that looks over, that looks over CT protocols from the standpoint of image quality, workflow, efficiency, and of course radiation dose. And that group does need a team of radiologists, technologists, and physicists. As I mentioned, there's a number of major medical centers that have this. The issue is, down the road, will this become a requirement of the Joint Commission or some other body? That, in fact, you have evidence that you, in fact, have such a protocol review committee that periodically meets, reviews things, and someone is taking a look. We need team decisions. We need to have the ability for a technologist that enters in a given protocol and sees that the value is 2 times what it normally is, to stop the line right there and call somebody and say, time out. We need now to take a look at this. What did I do here? And why is this number so much bigger than the other ones? We need to have discussions about image quality and dose. We need to advance the idea that there will be a national registry where the dose index will be monitored so that individual places will know where they are with respect to certain studies. And then there's a trade-off involved. If, for instance, the institution is 5 standard deviations below the mean for the CTDI of all for head CTs without, maybe they should be looking at their image quality. If they're 5 standard deviations above the mean, maybe their dose is more than they need to be doing. We need more of these kind of settings right here, public workshops and forum. A wonderful thing that was put together by Bill, Diana, and Cynthia, and I think we need more of this. We need to raise awareness, and we need to begin to teach the way that people can take care of this. And then of course, there's a website being put up by the AAPM that would have protocols so that people can go to a kind of disinterested third party that has vetted some protocols so that they can see for their scanner what is the recommended or what is the suggested type of protocol and the dose value. And we need that these details need to be widespread and they need to be transparent. We need to have this done in the open now so that all parties have a voice in here. And then I think we need to work together with the vendors to further enhance ways that we can work together both in the design before the systems are released and as well afterwards, so that they will know what we think is the right thing so that they can do the right thing. So I think this is the dawn of a new time. I think that this is a new era that we're going into, and I think that dose will become important certainly in CT, but in other areas as well, and that we should take advantage of this. And this opportunity is a wonderful time for us to help one another to optimize the protocols and optimize the radiation that's used in producing high quality images for the successful interpretation of patients. Thanks.
Please come to the microphone for questions. Bob?
I'd just like to make a comment of a future we'd like to avoid in Germany. If the radiologist wants to exceed the reference level on a patient, he can do so, but he has to submit something in writing justifying why that has happened. So in Germany, dose rules are on a much higher level than here, and I don't think we want that to happen.
I think that's why we should be out ahead of this, that we should not be – I don't think we should wait for regulation. I think we should just do the right thing now.
Something that everybody in the room can do when they get home, add this to your to-do list, is to check your localizers and make sure that nobody's using AP localizers. We should all be doing PA localizers. That's like how we do chest exams to reduce breast dose, especially on pediatric females. So this is, it's not going to change the overall dose very much, and it won't show up on the dose report at all because that's not, the scouts aren't included. But it's something that we can easily do and we should be doing, and that's one of the things that's often not set properly on the default protocols.
That's correct. I think actually pediatric males would appreciate it as well.
Stephen Vostok-Maita, the role of physicists in improving the dose in facilities is critical, and more information is showing that. Are there any plans in AAPM to conduct studies to compare dose data from institutions with full-time physicists on staff versus without that kind of resources?
I'll let the President-elect answer that one.
Well, I'll defer to the Science Council chair who's standing at the back of the room. No, actually, there certainly should be some things that we should look at to see if there is a difference between those that are in academic situations and always a present versus the consulting physicist. I think maybe Bob Pizzatello can comment upon that in his talk tomorrow.
Chad Dillon with Alliance Medical Physics. One of the things your talk assumes is that we're getting the scanners directly from the vendor when they're new, and you're always having vendor support. But with the economy the way it is, especially in smaller rural facilities, you're getting third-party transactions with the scanners, and then a third-party cheap service engineer comes in, not to knock them, but comes in and does the installations, and there's no good application support from that point. So I think the AAPM protocol page is a great step forward in addressing that kind of issue, but it'd also be good on, I can't tell you how many times I'd like to, for my site to contact the vendor of the machine and get some application support to figure out what the best thing is, and they just can't do that because they don't have a service contract. So I think if the vendors could somehow come up with maybe some kind of applications support by itself, that would be great for those third-party type transactions.
Yeah, I didn't have time to talk about applications, but as all of you know that do CT, applications vary tremendously. And so sometimes you have experts that are there to help out, and other times you have people that barely know all the buttons to push. And that is an issue. Mark?
Just a couple quick comments. One regarding CTDI reporting. For a pediatric abdomen, some vendors are using the 32-centimeter acrylic phantom. Some are using the head phantom. Some are using a pediatric phantom to calculate or estimate CTDI doses. And we need standardization there. And people need to be aware of that the doses reported for peds may be way off. The second comment regards protocols. On my scanner, when I downloaded the protocols with the assistance of the vendor, there's 55 parameters that describe each protocol. There's more than 300 protocols on each machine. In those protocols, they do not indicate which bow tie filter they're using, which of three different, they have 4 bow tie filters, they have 3 different beam filtrations. It doesn't come across in the protocol. The vendor chooses it. I don't know if they've chosen the right one. How can physicists sort out these protocols when we don't have all the information? It's not coming to the DICOM header, and we don't know what each vendor is doing.
I think that the answer to that is kind of from Top Gun. It's complicated.
Yeah, it certainly is. Yeah.
I don't think that we can't solve this today, but I think that the ability of the vendor to transmit that kind of data is something that we should talk about in the future. I think that it would be important to the physicist. It's not going to be important that much to some others, but it would be important to the physicist in terms of dose. Right now, we make an assumption that they've optimized the scanner using whatever techniques they have to keep the dose as optimal as possible for that body part.
Mm-hmm. All right.
We're just about running out of time, so we have 3 more comments. Make it short, please.
Okay. I will try to be brief. This is really a plea to the manufacturers. It's happened to me on several occasions that while we have worked very hard to optimize our protocols for our institution, for our radiologists, an applications person has come in subsequently, decided that he or she did not like the protocols we had, and unilaterally changed these. If the vendors want to learn from us, as you stated, then they cannot be doing that. If there's a question about what the protocol is, come and talk to us. Don't just change it unilaterally.
Agreed.
The ACR Accreditation Committee is actually currently working on updating the protocols they currently have in their clinical image guide. And Bob Zeman has been spearheading this effort. They're not addressing individual manufacturers, and they're not getting down to specific MASs and things like that. But they're talking about contrast, injection rates, everything that goes into a CT exam. So I think it might be worthwhile extending the discussions.
Thanks, Penny.
Last comment.
It was mentioned how the CTDI vol doesn't really reflect, in many cases, the pediatric doses, and I saw Kimberly Applegate kind of raise her fist back there. So I just wanted to tell everybody that as a result of recent discussions, we are activating a task group that will look into that and provide a table that should allow fairly accurate pediatric doses to be calculated from 32 and 16 centimeter diameter PMMA, CTDI measurements, and we promise to have that by RSNA.
That would be the Strauss table?
In effect, yes.
Yeah. Well, that was the last comment. One of the things about that pediatric field of view, if the technologist uses the wrong field of view, uses a large field of view, guess what? The scanner is going to use the large diameter phantom as the dose index issue. So you have to make sure that the protocols are done correctly. We're at a break. We're right on time. Bill, did you want to say anything?
We will start
exactly at 11 o'clock. Be here, and we will continue on the excellent talks. Thank you very much.